Okay, so good afternoon, everyone. My name is Jesse, and I'm with Exploring by the Seat of Your Pants. For those who don't know, we're all about bringing conservation, adventure, and science into classrooms around the world. We're really excited this week, especially because this week we are building up to Friday's World Oceans Day by having a week-long celebration featuring 50-plus researchers, explorers, scientists from around the world working on oceans, ocean animals, oceanography, all the oceans. It's very exciting. And so we thank you so much for joining us today. Right now, we've got 4 classes from across North America. So I'm going to give them a chance to do a bit of a shout out, and then we'll introduce our speaker. So first, who else but Mr. Elsa's class from Burlington, Ontario, grade 4s. Hi, guys. Hi. There are a lot of you. Okay, we have Miss Smith's grade 7s in North Royalton, Ohio. Hi. Older kids, the pitch gets that much deeper. I love it. We have Miss Reeves, grade 4s in Leamington, Ontario. Hi. And last but not least for now, we have Miss Sinclair's grade 2s in Kalispell, Montana. Hi, guys. Very high pitch. Okay. Of course, the reason you guys are all here today is for our speaker. We're joined live by Dr. Liz Burgess, who is at the Cabot Center for Ocean Life at the New England Aquarium, and her research centers around this interesting idea. Now, when you want to do a checkup for you, you can go to a doctor's office, but it's very hard to get a whale into a doctor's office. And so Liz's research figures out how you can take the health of a whale without getting into an office. I won't give away any more spoilers. Without further ado, Liz, thank you so much for joining us today.
Hi, everyone. All right, I'm going to share my screen. Is that working?
Yeah, you're good to go.
All right, so we're going to go on a wild ride today because this is a question that I'm going to get you all to think about. All right, Jesse's just given us a really great introduction, but how do we give a health checkup to a very large, free-swimming whale at sea? But before we get there, I'll just give you a little bit of a background to myself. So I'm an Australian. I was born in Sydney and I grew up in Brisbane. Whoops, excuse me. Gotta go back. So this is where Brisbane is, right on the coast. And so I did most of my schooling in Australia and a little bit in New Zealand. But I went back to Australia to do a study on dugongs. Now, most people in the world don't know what a dugong is, but it's a marine mammal. And I really like talking to North Americans about dugongs because you guys are generally familiar with the Florida manatee. So the dugong is a distant relative of the manatee. And so in studying these animals, I started to ask questions about wild populations and the health of wild populations. So not just about mortalities, but how are they reproducing? How many calves are they having? And are they healthy overall before we see any lethal effects? So these are really quite complicated questions, but they're very important. And so I did my study on dugongs, got some expertise in this area, and that's what led me all the way to the other side of the world to Boston to join the Anderson Cabot Center for Ocean Life at the New England Aquarium. So that's actually where I'm calling from right now. And so the aquarium was a really good place and a very important place to continue asking the questions that I had started with the dugongs, because at the aquarium, they have a very long history, over 40 years of studying this particular animal, which is the North Atlantic right whale. Now, this animal is very important to North America. It migrates across the entire eastern seaboard, so from Florida all the way up to Canada. And there's only 450 individuals left in the entire world. So that's really low for a wild population. So it's classified as critically endangered. If you think about all the kids in your school, it's likely to be more than there are of this particular species. And the aquarium has been studying this animal, and all of the individuals are identifiable. So if you see on the very head of this whale, you can see these white clusters here. We call these callosities. And the aquarium uses the patterns of these callosities to be able to identify each and every individual. So there's quite a large catalogue that you can actually look up online if you want to try and see how many individuals there are and get to know each individual. So I can give you the link for that if you're interested afterwards. These whales were originally reduced in numbers due to commercial whaling in the 17 and 1800s. So they're referred to as the right whale, not because left or right, but because of right or wrong. So they're considered the right whale for whaling, and that's because they have a really thick blubber layer so that when the lethal blow is delivered by the whalers, the animal actually floats. So it's very easy to pull in. So their numbers were originally brought down by very early commercial whaling. However, these days, right whales are dealing with a lot of impacts in our oceans. So they migrate along the eastern seaboard, as I mentioned, which is very heavily populated by people. There's a huge amount of shipping traffic that comes into these ports. There's a lot of runoff from the land, pollution, plastics find their way into the oceans. There's a lot of fishing activity, some of which has permanent gear in the water. And then also we're dealing with a very big temperature change in this region that the North Atlantic right whale is migrating through. So all of these have an impact. And so when we think about ocean conservation, quite often we don't see these impacts. Because when we look out to the oceans, this tends to be what we see. So a lot of the impacts are underneath the water. All the noise we don't hear, but water is a really efficient carrier of noise or sound. And so the whales are often living in a very noisy environment. They encounter foreign shipping traffic coming through. So all of this creates quite a big problem for the North Atlantic right whale and protecting the species. So these questions about population health come into play when you're dealing with such low numbers and such a complex environment with so many impacts that these animals are dealing with. And so up here on the land, if we want to check how our health is doing, what we tend to do is go to the doctor, and if there's grave concerns, the doctor might actually send you off for a blood test. And so blood is really important to our bodies. It carries a lot of molecules, right? Molecules that are really important to our health. So by getting a sample of blood, you can get a lot of information. And one of the molecules that blood carries are hormones. And so I'm going to talk a little bit about hormones in my presentation today, because these are the biomarkers or the indicators of health that we really zone in on for wild populations. So a good example of that is progesterone. So the hormone of progesterone is primarily a female reproductive hormone, but it has a really important role in maintaining gestation or pregnancy. So if a female has high progesterone, it's likely that she's going to be pregnant. Another important one is estrogen. That also comes into play for female reproduction. So knowing if a female is mature or immature. Testosterone is the masculine hormone. So that's really important for males to mature. And another important hormone, particularly when we're talking about health, is cortisol, which is part of a group called the glucocorticoids. And this is your stress hormone. So if you're feeling very nervous or jittery, or you're worried about something, or you get a scare from something, it's likely that cortisol is going to highly increase in your blood. And its main role is to release energy so that you can fight or flight if you want to. So blood is a really important sample to be able to give you an information about the health of an animal. But it's impossible to sample blood in a whale. They're just too big, the blubber layer is too thick, and there's no way that you're going to be able to handle or bring a whale up onto shore safely in order to collect a blood sample. So as scientists, the questions we want to answer, we can't use blood. However, a lot of the molecules that circulate in blood, and hormones in particular, are eventually eliminated from the body. So they don't stay in there in continual circulation. Once they've done their job of acting on the organs, they'll then be excreted by the animal. And this happens in humans as well as all other mammals. And one avenue of excretion is for the liver to extract that blood, process it, and then it pulls the hormones into the gut tract. And then from the gut tract, it gets excreted out. So a really important sample for looking at whale health is poop. And so poop has all these molecules that are representative of what has been circulating in the body. So that's the approach that we take for large whales. So we spend a lot of time on the ocean, researching whales, observing whales, looking for whales, and then hoping that we get a poop sample. So this here is me collecting a fecal sample straight off the water. I've used a net to scrape that in, and then right here in the pot is me putting a bunch of poop in there to keep it preserved and so that we can analyze it in the lab. And this picture doesn't fully do it justice, but that poop is pretty much exactly the same color as my bright orange jacket. So North Atlantic right whales have bright orange poop, and that's because of the diet that they eat. So we get a lot of success just being out on the water and following whales and opportunistically finding a poop sample floating on the surface. Not all whale poop will float, but for the right whale, their diet is fatty enough that it will float at the surface. So that makes things a little easier. But it's extremely hard to find still, because you can lose track of the whale, and that's just a tiny poop sample, even though it's come from a large whale floating in a very big ocean. So we needed to think about this a little bit further. How can we maximize the number of samples that we can collect? Because we can't, like, waiting for a whale to poop all the time is very time consuming. So we need another approach. Now, have a think about what might be really good at finding poop. And anybody that is a dog owner, you might want to give a little sly look at your neighbor, because dogs are some of the best sniffers in the world, and they're very good at sniffing out poop. So Dr. Roz Rowland here at the New England Aquarium had this idea. Why don't we get a dog on the boat and we'll train him up to be a poop sniffer? So this here is Fargo. Fargo was a Rottweiler. Fargo originally had a job in the drug squad. So he worked for the Washington State Police looking for narcotics. And during his retirement, he was getting a little too old to keep that job up. So he got a job on our boats, trained up to find North Atlantic right whale poop. And Dr. Rowland was trained up to be a conservation detection dog handler. And so a lot of dogs actually have jobs in conservation trying to protect wildlife. So it's really quite fascinating to see all the many jobs that dogs can have. But Fargo was particularly suited for life on the water because he had a very broad stance as a dog species. So that made him a little bit more stable while he was at sea. And with his nose, we were able to increase our sample collection by 4 times the number of samples per hour than if we were just using our human eyes and human nose. So I'm going to show you now a little video of Fargo in action. Here we go. So he's wearing a life jacket, just like everybody else on the boat. And he's being held by a leash because when he finds a sample, he gets very excited. So we wouldn't want him to dive off the boat. Now, a key sign here is the wag of the tail. So the faster the tail's wagging, the more likely that you're going to find a poop sample, and then he's on the scent trail. And so you're seeing Fargo go from side to side in the boat, and he's just picking up the scent trail. And then the person driving the boat is following Fargo's direction as to where to go as that scent is coming from upwind. So we're traveling upwind. When he finds a poop, He gets a ball as a treat, and there you go, a whale fecal sample floating on the water. And then our job as a scientist is to scoop that up and preserve it. So that was the fecal sampling, and we've gotten a lot of really important data on the health of right whales based on feces. But there is still the challenge of having to wait for a whale to poop. So we put our minds to the test again, and we thought, what's another way that we can try and sample hormones in a whale more efficiently? And whales are tied to the surface for breathing. So a big challenge for most marine scientists is their animals will dive below the waves, below the surface. And we humans are not super comfortable down there. So we're tied to being at the surface. So we're having to wait for the whale to come up. But luckily whales, or working with whales, is that they are tied to the surface for breathing. So they're air breathers just like we are. And when they come to the surface, whales have such large lungs. And so their exhalation, that breath out, tends to be quite large. So you'll get this big blow cloud, which is respiratory vapor that's been blasted out of the lungs at quite a fast velocity. It tends to condense down in the warmer air outside, so you tend to see these like clouds above the whale. And so because whales have such large lungs and they're highly innervated by a bloodstream, some of the molecules that are in the blood will also come out in whale blow. So we decided, maybe we should collect that. And fair enough, there are hormones there too. So that was our next task, was to continually collect a blow sample from whales at sea. And in order to do that, we rigged up a very large pole. This pole here is 9.7 meters. It's made of carbon fiber, so it's fairly lightweight. This here again is Dr. Rowland at the lead collecting the samples. And at the very end of the pole is a very large petri dish. And so the idea is to swing this pole out over the whale without having to touch the whale or disturb the whale. And as it breathes, collect the sample, swing the pole back on board, and there we go. So here is an example of a whale blow or whale snot sample. So this is what is at the end of the pole. It's a very large petri dish. And you can see all these droplets here are some of the sample from the whale. And so here's a little video. At the end here is a slightly different device than the petri dish. So part of our science is like perfecting these techniques and improving these techniques. So for a while there, we were using a mesh rather than a petri dish. So here is a North Atlantic right whale. You can see these callosities here are quite long on this individual. This is quite a cold day, so when the whale breathes, you won't get to see like there's a blowholes, they've got paired nostrils just like us, opens up, and we've got our sample. And amazingly, what you're going to see here with the animal is that it hasn't picked up speed and it goes right back to feeding. So this animal is doing what we call skim feeding. So it's dropped its lower jaw, its top jaw is wide open at the front, and it's just cruising along the surface of the water, trying to skim the copepods out of the water. So blow sampling has been really successful also for looking at hormones, pregnancy testing the whales, and we're starting to look into stress in that avenue as well. But it's a very new technique, so we're really just getting underway there. But right now, I want to go back to fecal sampling and tell you a little story about this particular whale here. This is a whale called Baylor, and Baylor was born in 2009. Which perhaps is the year that some of you were born or thereabouts. And the tragic story of Baylor was that Baylor got entangled in fishing gear. So Baylor was still quite young when she got entangled. And so what you're looking at here is all these ropes, right? So she's managed to get herself tied up in this fishing gear. This is the start opening of her mouth here. So the rope has come in and it's all tangled up inside her mouth. And she's not able to free herself. So she's gotten herself really trapped in these ropes. And it's highly likely that she's dragging pots or some other heavy gear that's attached to these fishing lines at the back. Now, compared to the previous photo, you can also see she's a lot skinnier here and she's very grey. So she's really suffering under this strain of being pulled by fishing gear. And the tragic story is that a couple of months later, after she was first seen with this fishing gear, she may have been carrying it for much longer before we saw her, but she was found dead. And so this here is the top of her head. This is her mouth open here. Her eye would be back here. This is her pectoral flipper, and then her tail goes along here. And this here is the baleen structure that she uses to filter feed. And you can see that rope is really heavily entangled. There's another loop coming here, right around the lower jaw. So unfortunately, she died from this entanglement. And this is really quite a common scenario for North Atlantic right whales. But looking at the fecal data that we're collecting and looking at the stress response. So along here, glucocorticoids are a group that includes cortisol that I mentioned earlier. So this is your stress response. So if cortisol goes up, the numbers increase, then so is your stress response. It's very active. And so this is the measure of cortisol, glucocorticoids in feces of right whales. This is a healthy group of whales. So they tend to be within a very narrow range and tend to be, this is a log scale here, so the average for this group is about 51 nanograms per gram. Whales that have been killed by a boat strike, so they've been hit by a ship, tend to be killed fairly suddenly. So the signature of the stress response that comes out in their feces tends to be similar to a healthy whale because that animal usually hasn't had time to mount a very dramatic stress response because ship strike blows tend to be lethal, so they tend to die almost immediately. Not in all cases, but typically. However, an entangled whale can drag gear for a very long time. So that gives plenty of time for a stress response activation and for that signature to come through to the fecal samples. And so we see this very dramatic increase in cortisol in the feces of large whales, including Bela, that I just saw. One of her samples is in this group here. And we're talking about orders of magnitude. So the mean for this group is 1,856 nanograms. If you compare that to the healthy whale down here, that's quite a dramatic increase. And this here is one individual whale. This is like one of the highest levels of stress response that we found in our samples, was a whale that stranded live. So it was quite traumatic, and that animal had very high stress levels, which signifies that. So Bela's samples, we actually got 2 fecal samples from Bela. One during when she was like seen with an entanglement, and then another sample at her death. So a healthy whale, we don't know exactly what Bela's healthy levels were, but let's say she has an average, 50 nanograms per gram. During the entanglement, it increased 3-fold. So 3 times her adrenal activity, her stress response has been activated. And then at her death, the levels measured 612 nanograms per gram. So that's quite an increase in Bela. So flow and feces have been really important for us to understand what is happening in the internal health of North Atlantic right whales. And most recently, we've started to look at another way of analyzing hormones and the health of large whales. So this is really new research, so I'm quite excited to share this with you guys. So this here is a North Atlantic right whale, and it's skim feeding, very similar to the whale that was seen in the blow before. So the top jaw is up, the bottom jaw is down, and this here is the baleen. So when you're thinking about whales and dolphins, some have teeth as feeding structures, just like us, But others have this baleen structure, which is a really phenomenal organ that is designed to filter the water and to extract any plankton, copepods, or small fish, depending on the species of whale and what they're feeding on. But baleen is, in fact, just like hair. So it's hair that has been compressed, and it grows from the top of the jaw right down to the end. So this here is one single baleen plate. So if you just think about one of those lines running down, that's this here. This here is where it would attach at the top of the jaw, and then it would roll down the mouth. So the baleen grows from this area, and it keeps growing and growing, and then you start to get frizzy ends, split ends here, and so it starts to break away, and the plate just keeps growing. So very similar to your own hair. So the amazing thing is that this area here is close to a blood supply. So what we think is happening is that some of the hormones in the blood supply along the gum here is being incorporated into the hair. So if we start to sample all the way down this plate here, all the way down the growth layers, we can start to see a timeline of what happened in this individual's life. And so that's what we started to do and started to ask those questions. So this here is a baleen sample from Staccato. Now the thing with baleen is it's quite different to blow and feces in that the whale has to have died for us to be able to collect these samples. But there's quite a big network, both in North America and around the world, where people will respond to whales stranding, and they will collect samples for scientific investigation. So this here is a whale called Staccato, and Staccato was hit by a ship. And so that was the reason why she died. We were able here in the lab to get a hold of one of her baleen shafts, and she died in 1999. And so based on the growth of the hair, we were able to figure out a timeline of what this one baleen plate represented in Staccato's life. So from 1999 right down to 1990, so nearly 10 years. And what we know about Staccato is that from seeing her in the wild, she had a calf. Oh, that's like a little bit off. Hang on. Oh, let's go back. Sorry, that image was supposed to be down the bottom here. That's okay. So if you can imagine 1990 here, and then towards the end of that year, she was seen with a calf, and then she had this like older calf present with her here in these white dots. And then again, a little bit later, so that's 1998, 97, again at the end of 96, seen with a calf, and then an older calf here. These black dots was when Staccato was seen without a calf. So what we did with Staccato's plate was we had a look at progesterone. And remember earlier I said progesterone maintains pregnancy. So we would expect to see really high peaks of progesterone just prior to the birth of Staccato's calf. And so when we looked at the hormone profile down this baleen plate, right here was where she was seen with a calf. So this yellow bar represents where we would expect a pregnancy to be. And then there you go, high progesterone. And then it drops back down. It's unlikely that she had any calves during this period from 1995 to 91. And then she was seen with a calf at the end of 1990. And wow, there's a high progesterone peak as well. So this is really amazing, because what it means is that we have an opportunity with just one biological sample to go back through time. And for scientists, that's quite phenomenal. So we're able to go back through time, have a look at all the pregnancies she's had over that last 10 years. If we wanted to look at stress hormones, we could have a look at potentially some of the stress peaks that have occurred in her last 10 years of life. The amazing thing is that baleen is often preserved in museums, so we could have a look at all that archive. And then even more amazingly is that a lot of Inuit and Indigenous communities have preserved these back through much longer history records. So we have this amazing opportunity to look back through history and have a look at how often these animals calved, or how often their stress or their adrenal activity was activated. So that's some of the newest science that we're getting underway, and there's like plenty of work to be done. But I guess I just wanted to go back to my story here, because as an Australian, most Aussies tend to live on the coast. And I know I'm speaking to a lot of you guys that are not near the coast or not near the ocean. And although I grew up swimming in the ocean and going to the beach all the time and being very much a part of it, I did my undergraduate degree in marine science. But I didn't see a whale until I was 22 years of age. And only then did I see it, because I managed to land a job as a commentator on a whale watching vessel. So my first day on the job, I saw a whale for the very first time along with everybody else on that boat. And I guess what I want you guys to take away from that story is that no matter what you're interested in, it's always within your power to learn and to read and to ask questions and ask your teachers. So even if something doesn't seem within reach, or you have never seen it or experienced it, then learning is a really powerful tool. And so whales can tell us a lot about our oceans. They migrate extremely large distances. They're some of the biggest migrators on our planet. So international borders and boundaries mean nothing to them. So a whale can migrate from southern United States all the way up to Canada. They can go from Antarctica all the way up to Australia and out to the South Pacific. And not only that, but they also migrate through the water column. So some species use the very deep parts of our oceans and then come all the way back up to the surface to breathe. So if we want to understand how healthy our oceans are, then whales are a really good way to do that, because they really know no boundaries. And that's really what our oceans are all about, is that what happens on one side of a continent can end up on another side of the continent. So we really need to all work together. Because up here on the land, we as land dwellers don't often think about what goes on in our oceans and with our friends in the sea. And with that, thanks for letting me be a part of your classroom.
Thank you so much for that, Liz. Outstanding. All right. So as you share off, we will pop over to classes and give you guys a chance to ask some questions. So we'll start out with Mr. Elson's class. You guys have a question? Come on up.
There you go. No, come on, right up to the front.
Yeah.
Hi. So, hi, I'm Owen. My question is.
Hi, I'm Owen. My
Come on, right so she can't see your head. There you are.
Hi.
Hi, Owen.
And my question is, how old do these whales usually get?
Oh, that's a great question, Owen. Well, we think that whales get to about 70 years of age or older, because the thing with a lot of large species is that they tend to live longer than the science has been going. So we're constantly learning about what the lifespan of these species are. And some species, like the bowhead, we think that they may live over 100, if not 200. So it's amazing how long these animals can live.
Cool. All right, let's go to Miss Smith's class.
Question.
How long are the teeth? How long are the teeth?
How long are the baleen?
Yeah.
Yeah, so in the North Atlantic right whale, a baleen plate will be anywhere between 1.5 meters to probably, yeah, I guess actually 1.5 meters is probably a good estimation. They get a little bit shorter and depending on where you get the baleen plate in the jaw. But right whales and bowhead whales have some of the longest baleen of all the large whales. So you can get a really long timeline there.
Imagine if your tooth was 5 feet long and you had lots of them all together. Very cool. All right, Miss Reeves' class.
How many whale species are there?
Oh, so of whales and dolphins, there's thought to be about over 80, so 86. And then of the large whales, you're looking at around about 15, I believe.
Cool. I love how that class has a microphone. Like, that is awesome. You guys are really prepared. All right, Miss Sinclair's class. Go right ahead.
My question is, how much whales have you seen?
Sorry, can you say that again?
Oh, how many whales have you seen? Sorry.
Oh, how many whales have I seen? Yeah. Oh my, that's a great question. And I'm going to answer that in terms of whale types, like species. So I've seen right whale, a humpback whale, a blue whale, southern right whale. Oh my gosh, this is so exciting. What else have I seen? A pygmy, a dwarf pygmy whale, sperm whale. Yeah, it's really exciting how much is out there.
Is there a whale you most want to see that you haven't seen yet?
Oh, probably my next, I mean, the beaked whales are always amazing because they're the deep divers. They're the ones that go, yeah, right down. So I've seen the Blainville's beaked whale, but there's a huge variety of beaked whales.
Very cool. All right, we'll go back to Mr. Elsa's class.
Green, come on.
30 questions in the class. I love it.
Okay, go for it.
How long have whales been living?
Oh, millions of years. So I think we want to go back to about 5 million years or thereabouts. So they've been on our planet for a very long time. And so the fact that we have so many populations that are threatened or endangered, you know, is really concerning.
It was, it's too bad that for that class that's there right now, the Royal Ontario Museum had a whole thing on the evolution of whales, showing it like wolves and bears.
Oh, yeah, fantastic. Yeah.
It's really cool. And I'm sure you can look up some of that information if you wanted to find out more. All right, Miss class again.
How big is the average right whale?
How big?
Yeah.
So the average adult is about 45 to 50 feet long, and you're looking up to 70 tons in weight.
Very cool. All right. Miss Reeves' class.
Okay,
Hi, my name is Junior.
That's okay. Take your time.
Is your most best whale in the world?
What is
Favorite whale?
my favorite whale? That is a really good question. So my favorite whale, and unfortunately I only know this whale by a number, but it's 3101, and it's a very important and special whale to me because she was the first whale that I sampled for blow, and she ended up being pregnant. So she was a very important whale in our database. So that's a great question.
Is she off the coast of Massachusetts? Where is she found?
Yep. So we saw her in Cape Cod Bay, but you know, she's likely in another area as we speak.
Okay. Awesome. Let's go to Miss Sinclair's class again.
How do you keep track of like their names when there's so many?
That is a great question. So I'm going to share my screen with you all because perhaps in your classrooms or at home you might want to have a look at this. But there is a catalog. So if you go to rwcatalog.neaq.org, that will take you to an area. Let me go back. So it'll take you to this website, and you can say, scroll through all the whales. And right here is a sketch that the scientists here at the Anderson Cabot Center for Ocean Life have drawn of what we expect to see on this particular animal and how to identify it. It tells her name is Fermata. Catalog number is 1001. She's a female, and she was last seen in 92. And then you can come over here and click next and go to the next whale and the next whale and the next whale. And so it's a really great resource that's online that you guys can use to have a look at. So all the whales that we've seen over the years are here. So some of them have passed away and some of them are still with us today. So it's pretty cool.
Awesome. I just sent that link to all the classes too. So you guys have that in Miss Reeves' class. You guys got to go. Do you want to do one more question before you go?
No.
No, you're running out? Okay, well, it's so nice having you guys, and have a wonderful rest of your day. We'll go to so we'll do 3 more questions. I know you guys are done your day soon. We'll be back to Mr. Elsa's class. You guys have
We're gonna hit you with 2 questions.
Okay.
Hey.
Go, Aaron.
How heavy can a whale get?
And what's yours?
How much can a whale eat?
Oh gosh, that's a good one. So how heavy can a whale get is up to 70 tons. And then, I'm not really up on my how much they can eat facts, but that is quite a lot of food to feed a 70-ton body, as you can imagine. And I mean, fascinatingly, these are some of the largest animals on our planet, and they feed on some of the smallest. Like, we're talking tiny little microscopic copepods and plankton. So it's quite phenomenal that such a large beast feeds on such a tiny one.
So just a really rapid look at for how much they eat for a whale website. NOAA mentions that in the peak period, blue whales can eat 8,000 pounds of krill. So I don't know how many days that's over, but that's a lot.
That's amazing.
Awesome. Let's go to Miss Smith's class.
Kevin?
You think you'll be able to get the right whale out of critical extinction?
Oh, wow. That is such an important question. You know, we have an entire team of people here working very strongly to put protection measures in place. We have a lot of support from the Canadian government as well as the US government. So collectively, we're really working hard together with the fishing industry and the shipping industry. So everybody's really on board. The challenge that we have at the moment is that what were fairly predictable habitat spots for these animals, they're showing up in different areas. So basically all the governments and the industries are really racing to get ahead of that so that we can put protection measures in place. So we have a really big battle ahead of us, but you know, we're doing our best.
That's good to hear. All right, we'll wrap up with one last question from Mrs. Sinclair's class.
No, Celeste, you've already had a chance. Thank you.
Yep, you're good.
How many times a year does a whale get caught in a fisherman's?
Oh, that's a really good question. So each individual has different levels of scars and incidents, but what I can tell you is that over 80% of the population has some scarring from entanglements. And so we can see these scars as white patches on their dark skin. And so most of the population has had some interaction with fishing gear.
Well, not excellent. Good answer. Unfortunate situation. So before we wrap up, just a question for the kids at home and the classes that are with us today. What can they do to help protect whales?
The best thing that you guys can do is when you get home tonight, tell somebody about it. Anything that you've taken away today, even if it's the color of whale poop or the threats that they face, or hop online and learn a little bit more, but tell a friend, spread the word. It's really important.
Outstanding. All right, so Liz, at the end of every hangout, what we do is I'm going to demute every class's microphone, and so Mr. Elsa's class, Miss Smith, Miss Sinclair, and Miss Reed, if you guys could join me in saying a big thank you so much to Liz for joining us today. So thank you, Liz. Awesome, guys. Thank you so much for the classes. We've got many, many more hangouts the rest of the week with, again, more amazing ocean researchers and explorers. Liz, that was wonderful. Thanks so much for joining us.
My pleasure. Thanks, everyone.